Hello, everyone. Welcome to our class. Today, we are going to talk about a very important concept used in the Rust, these programming languages. It's about a scope and also reference. So if you are a C programmer, you will feel like this is a little bit different to what you understand when you work on a C or Java, these like a traditional typed programming languages. So Rust is typed programming languages, but it's also these languages give some give a lot of flexibility. For example, on your memory management, or give you some availability like define a value, define a variable. But it's also like try to give some restriction to to implement to support this flexibility, so it can still compile it as a very efficient, very a good executable file without too much problem because of this restriction. So let's look at what's the scope, what's the reference, what's the ownership in Rust. So scope, what's scope? Scope is actually a range of a program. So inside a program, you try to use a scope to control the variable's lifetime. So in this case, we use a parentheses as a scope. And every variable is valid only in the current scope. So in this example, if we have a scope here, and we define a variable here, the variable only lives inside the scope. Before you declare this variable here, it's invalid. So it's invalid. After you declare it, it's valid until what? Until this moment. After this moment, because you already finished the scope, which means the S is not valid again. So the variable is live only inside the current scope. If you define the variable in a scope, then out of the scope, the variable will be disappear. Okay, so this is about scope. And in Rust, there's a specific, very important concept about scope is here. The memory is automatically returned when the variable inside the scope finish. It's automatically. So you don't need to do a garbage collection because the Rust, these programming languages, manage this variable value memory you use inside the scope. They manage this for you automatically. So this is good. This is good, but it might cause some weird behavior or problems when you write the Rust program. For example, if we write this code, we try to do what? We try to define a variable s1, which is equal to string, right? So we define this. This is correct. So in behind the scenes, what it actually do is create a memory space. It's allocate the memory on your heap. Try to get the whole bunch of the value, the string value, each character in a heap. And of course, there's an index to help your compiler to find the string. So it's the same as a C. It's the sequence of character, right? So it's create the data on heap. That's totally fine. And right now, if we try to do S2 equal S1, what we will do is we copy the value of S1. What's the value of S1? It's a reference. It's an address of the data the string. It's copy the value address of the string as a S2. So which means the S2 can reference, can refer to the same data in your heap. Okay. However, here's a question. Based on the previous slides, we know when you finish the scope, it will automatically collect the data, collect the memory back for you, right? So in C languages, we don't need to worry about it because C, you need to do the free by yourself. If you malloc, you do a malloc, you do a cloc, you allocate some memory on heap. You need to do a free to release this memory space on heap, right? So in C, you have to do this by yourself. In Rust, you don't need to worry about this memory management because the Rust will manage this. But here's the thing. If a two variable refer to the same data in the memory, which means if we run the scope here, scope is finished. We want to say this S1 is finished. So we try to release this memory space. And S2 is here. We try to release this again. This causes a problem, right? Because we try to release the memory twice. Because we defined two variables inside the scope to refer to the same data. And after the scope, if we want to free this let's say pointer, because it's a reference, right? We reset these pointers twice. It will cause problem. So how your Rust programming languages support this? The Rust has a small way to deal with this. Actually, when you define as one, yes, you have this data start on a heap. But when you define another one, it's actually disable the S1. So S1 is no longer valid when you have say S2 equal S1. Only S2 refer to here. S1 is nothing. If we can do this, after we have a scope, we only collect S2, right? So we only collect once. So this is how the Rust programming handle this. So from this example, you can see what it's actually do is what? It's actually try to change the ownership of the string. So if you have a string on data, it changes ownership from S1 to S2. Okay, so this is about this is about the concept, the deeply like how it's actually implemented in Rust programming languages. So we call this ownership. For each data, you might have ownership. If you have S1 defined string, blah blah blah, you say S2 equals S1, and you try to get the S1 again, you will get error message. Why? Because S1 already gave out the ownership to S2. So S1 does not have any information. So if you want to try to print S1, it will give you an error message. Okay, this is about ownership. We give the ownership of the string from S1 to S2. If S1 gives out the ownership, then S2 take it. S1 does not have ownership. Then S1 means nothing. Then you cannot use it. If you want to keep remember the S1's ownership, what we should do is we need to do a clone. When we do a clone, S1 get the data here, we copy it, then make it S2 to point to this. So the S1 does not give out the ownership. You just get another copy of the data on the heap and allocate the memory on the heap again for the same data. So in this case, you can still keep the S1 without any issues. Okay, so this is very important concept in Rust. It's about ownership. So let's look at this example. This example, we have an X, which refers to a string, right? So when we call a function, it's actually also give out the ownership. So when we call a function S, if we have a data here, original X refer to here, right? But when we got this S passed to the function S, because we give out the ownership to this some string, so right now some string refers to this data and remove this reference. So if you try to access the S after this function call, you will get error message. Okay. However, here, if this is an integer, this is number. This number does not. This is not a reference. This is just a number. In this case, you can pass the number, copy number to 5 here. So it won't give out the ownership. So what the ownership is? It's also related to the reference, related to the pointers. If you try to give an address, it's kind of the part of the ownership, like a transition. So you need to pay attention if the data you pass is not a primitive type. So in this example, if you try to give an ownership, if you want to take back the ownership, you want to do this. So in this case, your S refer to this data, and you give out ownership in this line. In this line, you give out ownership. So right now, A string have a data here and remove this line, remove this reference. But here, because you try to say s equal to this one, and here you return this reference to this s. So you got the s here and take back the reference. So in this example, the x give out the ownership to A string. Then A string do something is return to the main function. So the A string give back the ownership back to the S. So actually S give the ownership to A string, the A string give back to S in this example. So this is how you actually write the code in the Rust. If you want to pass the string to a function, which means you give out the ownership, you have to return this reference, reference of string to the main function and use other variable to get the same function. Otherwise, you cannot you cannot like use s anymore in the main function after you call it. Okay. So now you kind of understand the ownership and the reference and what's the scope. Here, let's talk about the reference a little bit more, because in the previous example, it's so inconvenient. If we don't want to, let's say we want to return numbers from the function. For example, I want to pass a string, I want to compute what's the string length, I want to get the number to return. In this case, I give out the string, I give the ownership of a string to the function, and there's no chance to take it back, right? So this is something inconvenience. So actually, reference is still a valid concept in Rust. Just like in C, we use address of a pointers, address of a variable, right? We use this example. So in here, we have an address. If you can use the address of this pointer, so the s itself point to this like a data, right? So you try to pass the address of this reference to a function. Okay, so this is the idea. So what we will do in this example is, first one, we have x refer to the heap data, but we pass the address to here, which is the address string. So we make the A string refer to here, refer to this reference. So it's very like double pointers concept. In C, you can have address of pointers. Use another double pointers, point to the pointer, right? So this is the same. You use the pointer, actually the double pointers, which is A string, point to your pointer, which is S. And S refer to the data on a heap, which is your string. So this is the idea. We can pass the address of a pointer, address of a string, to another function. Then we can compute for example, the length, or we can do some like computation, how many digits in this string. We can try to do this like and return a number, right? So this is something we can do in reference. Here's the things. We cannot do this reference. Why? Yes, you can pass a reference. This is a string. You have a reference address of S, and this is address string. But why this is not valid? The reason is that, remember, by default, the variable is immutable. They are immutable. So you cannot just try to like update an immutable file, immutable string, right? So when you pass this string, this is immutable. And even though you give the ownership to this A string right now print out the same string, it's still immutable. And you try to change it. Means you want to change the immutable data. So this causes a problem, right? So in this example, it's not about the reference, not about the address. It's about what's the data what's the data's like a permission? What's the data status you have? If it's immutable, you cannot change it. How to change it? You need to say it's immutable. So actually in ROS, it's very like an interesting way. You can define this address is for a mutable string. Okay. And here you also need to say this address of a mutable string. This is a mutable string. So you need to specifically tell this string is mutable. Then when you call a function, you pass a mutable string, and inside the function, you take a mutable string. Then you can start to do this. So the whole bunch of idea in Rust is that, okay, that's a reference, that's ownership. And also there's a mutable, immutable, this concept. If you combine this whole bunch of like concept together, it will getting more complicated. It's will getting more like some kind of difference, like a behavior than your C programming languages. But if you understand the mutable, the ownership, and also reference, you will feel like it's much safe to write the code in Rust. If you understand this example, let's move on to look at the concept, like what's behind the scene in this example. Actually, there's a reference restriction. So what's a reference restriction? Only one mutable reference to a particular piece in a particular scope. So in the same scope, you can only have one variable has a mutable reference to the data. Okay, so which means in the same scope, you cannot have two variables refer to the same same reference, like same string, and these references are mutable. You cannot do this. Okay, so why? Because we want to keep this program away from the data race. So we don't want to have any like a conflict. If it's a multi-thread programming, multi-thread program, we don't want to have a race condition on these data in any way, or we don't want these two different variables they refer to the same reference, same string, and they update it like synchronously. And the first one can update this, the second one also update it. We don't want this to happen. So this is an example. If we have a string here, we say this is a mutable x, this is a mutable s, it will say no, you cannot do this because you have a multiple like a variable R1, you have two variables here, R1, R2, they both refer to a string and they both want to change the data. So this is not allowed. Okay, so you can see there's some like restrictions in Rust programming to help us for what? To help us to have a safer, much safer memory management.
Joe, I have questions. I am wondering if I really want to have a two variable use like a reference to refer to the same string. How can I do in this case? Sometimes I feel like one variable is enough. I need two. What can I do?
This is good questions. Okay, so let me show you an example how to like use two different variables to refer to the same string by using the address reference. So in this example, you can see this is fine because what? Because of scope. If you want two different reference to refer to the same string, you can actually use a scope. Inside the scope, there's one part, one reference to here. Because out of scope, when we got this moment, we remove this reference, right? So we already remove this reference. Then we can continue to assign this reference to a string. So this is some way you can do if you really want different variable to refer the same string. In this case. So this is for today's lecture. I hope you enjoy it. So today we talk about ownership. We talk about reference. We talk about scope. This concept for Rust. Rust has some restriction on this like ownership on this reference. The purpose is that the Rust want to keep your memory management much safer, and it want to like avoid the race condition data race. These like bad situations if you try to use a multi-thread program, or you try to do some synchronization, it's give you a much like safer environment to run this program. So if you want to have these environments for your implementation, ROS is definitely a better idea for you. But if you like to have a more flexibility on the pointers, on the edges, on this whole function reference like a concept, then you probably want to use C to build your application. Okay, so I hope you enjoy the ROS, these programming languages. I hope you enjoy today's video. See you next time. ROS programming, the scope, the reference, the ownership is awesome.